Hey there, this is Mrs. Sharp here to help you with some advanced chemistry 1.3, that's limiting reactants and figuring out excess reactants that are left over after reaction. So I thought what I would do is take your actual learning target assessment and go through with you that problem just so you could see another example problem here. So here's our information about this particular reaction. I've got 0.46 grams of antimony 3 oxide and 0.5 grams of carbon. First thing that you want to do here is definitely balance this. So I've got 3 oxygens here. If I make this a 3, then that gives me 3 carbons, and then I got to take care of my antimonies, which are 2. So that's definitely the first step. The next step here is trying to find the mass of a product, carbon monoxide. In order to do this, we need to find the limiting reactant because that's going to tell us what mass is actually produced. So I'm going to start with this information right here. I'm going to see how many grams of carbon monoxide I could make using either one of these two masses. So the number of grams of carbon monoxide is 0.46 grams of Sb2O3 for every 1 mole of Sb2O3. I'm going to have to find a molar mass for that. Okay, let me do that real quick. It looks like antimony is going to be, let me find it here. Antimony is going to have a molar mass of 121.8. And I'm going to add that to 16 times 3, which is 48. That gives me 291.6 grams per mole. Okay, next then is my mole ratio. So for every 1 mole of Sb2O3, I have 3 moles of CO. And since I'm doing mass, not just limiting reactant, I have to do one more step to find the mass of CO, and that's CO's molar mass. So for every 1 mole of CO, how many grams? So that's 12 plus 16, that's 28.01. So remember, double check all my units cancel here. And now this would tell me how much CO, how much carbon monoxide should be made with 0.46 grams of antimony oxide and enough carbon to make the reaction go. So let's see what that comes out to be. 0.46 divided by 291.6 times 3 times 28.01. That gives me 0.13 grams. Okay, so I'm not done yet because I have to double check and see how much is made with the carbon information. So I'm going to see how much carbon monoxide could be made with 0.5 grams of carbon now and compare those two. So 12.01 grams of carbon in 1 mole. That's easy since it's just an element. For every 3 moles of carbon, there's 3 moles of carbon monoxide. And then for every 1 mole of carbon monoxide, there's 28.01 grams of carbon monoxide. Okay, so again, I'm going to make sure my units cancel. Okay, and punch that right into my calculator. So 0.5 divided by 12.01. Okay, times 3 divided by 3, don't need to worry about that. So times 28.01. 1.17 grams. So that's not what actually is going to be made. So 1.13 grams is actually going to be made because it's limited by the amount of Sb2O3. So the limiting reactant is Sb2O3 because it causes less product to be made. Okay? So this is saying if I have 0.46 grams of Sb2O3 and enough carbon to do whatever I want, I can make at max this much. This is saying if I had 0.5 grams of carbon and enough Sb2O3 to do whatever I want, I can make at max 1.17 grams. So put those two together, you're going to make 0.13 grams. And that means you're going to have some C left over. Okay, so let's go down to part C. This seems to be the thing that you guys are struggling the most with. So, based on your response to A and B, how many grams of the excess reagent will be left over when the reaction is complete? Well, first, make sure you know what the excess reagent is, a reactant. Sometimes you guys are using products. These cannot be used for excess reactant. It's either this or this, and you told me that this is the limiting reactant, so the excess reactant is carbon. That's the one that didn't get all the way used up. So I always put carbon. That's my excess reactant. So the first thing we need to find is the number of grams of carbon used up. If we want to know how much is left over, we have to figure out how much was used up first. What number do you use? You have to figure out how much carbon is used up to make this amount, 0.13 grams of carbon monoxide. So we're working backwards. If I'm going to make 0.13 grams of this, how much of carbon is that going to require? So if I've got 0.13 grams of CO, remember 28.01 for every 1 mole, and for every 3 moles of CO, I need 3 moles of carbon. And for every 1 mole of carbon, it takes 12.01 grams of carbon to make 1 mole. Okay, so we are figuring out to make 0.13 grams of carbon monoxide, how much carbon is that going to require? 0.13 divided by 28.01 times 3 divided by 3 times 12.01. That gives me 0.06 or 0.056. Go ahead and use 2 sig figs. Grams of carbon used. Okay, so I've got 0.5 grams of carbon. It's only going to take me 0.056 grams of carbon to use this, and then the Sb2O3 is going to be gone. So you're going to have a bunch of this left over. How much left over? You're going to take your 0.5 grams of carbon at the start. You're going to subtract the 0.056 grams of carbon used. And that gives you trying to do the math in my head. It's just not working today. 0.056. 0.444. That's what I was going to say. So that is your answer. So look at these two parts. One, we figured out how much was used up based on the actual product made. Okay? So we figured that out based on the actual product made. Then we figured out how much was left over by taking our initial minus our used. Hope that helps. If you wanted to talk about a reassessment, let me know. We'll make that happen.